This graph illustrates, using some of the mathematical functional forms in the text, how the price of a pollution permit or a pollution voucher on the cap-and-trade system emerges. How much a firm would be willing to pay for a voucher that allows them to produce one more unit of output depends on how much additional profit the firm believes it can get by producing one more unit of output. This depends in part on how much consumers are willing to pay, an amount given by the marginal benefit curve drawn here. This marginal benefit curve is simply the demand curve given in equation 21.1. It also depends on marginal costs, which are incorporated in supply curves. The marginal cost curve here is simply the supply curve derived from the supply function in equation 21.1. The introduction of a cap-and-trade system that introduces a price for polluting will result in an output quantity produced by the market that lies below the market quantity xm, which would exist in the absence of a cap-and-trade system. A relatively large amount of pollution permits might restrict the quantity that's produced by the market by only a small amount, leading to output quantity x2, for instance. Cap-and-trade systems that restrict pollution further would lead to greater reductions in market output, reductions to quantities like x1. In a cap-and-trade system that leads to a reduction in market output to x2, the most that a firm would be willing to pay to receive a voucher that allows it to produce one more unit of output would be equal to the vertical distance between marginal benefit and marginal cost at the market quantity x2. And the more the cap-and-trade system will ultimately restrict the output level that's produced in the market, the more value there is for a producer to get permission to produce one more unit of the output. In other words, the more each firm will be willing to pay for the right to produce one more unit of output.